Hey everyone, continuing with our combinations, we'll be looking at the y portion. So it's actually the same thing, alright? So let's say we want to go from gy equal to hx to gky plus alpha. Again, you need to translate first and then scale. So first you get to gk plus alpha, sorry, y plus alpha, and then scale because you wouldn't want your translation to be affected by the scaling. Alright, but again, you can do scale first then translation, but don't forget to scale your translation as well. Alright, so y to gy plus alpha, then apply the scaling because everything you do only affects the y variable. So that is the same thing, really. So for gy equals to hx, whether it's it for y or for x, usually you would do translation first, followed by scale. Okay? But for the case of y equals to fx, then it's a bit different. Alright, so why is it different? Y equals to fx, your transformation may look something like this: kfx plus alpha. Of course, if we can talk about even better combinations, you'll look something like kfhx plus beta plus alpha. Basically, you do a combination of the x and the y, not just in terms of scaling and translation. Essentially, you translate x, scale x, and then you do scaling and translation for y. However, alright, for this case, there is a difference for the y variable. Alright, so if you're to get this particular case where you get kfhx plus beta bracket whole thing plus alpha, then these are the steps you should follow. Alright, start off with the x variable. So start with x. Alright, always start with x. Idea is, again, first you translate, then you scale. Alright, so I'm going to write a and m. This will come in handy later on. After you're done with x, now you deal with y, then y. Alright, so 3 and 4. Alright, now for y, here is a trick, is that you need to scale first and then translate. It's the opposite for the case of y equals to fx. Why is that so? Okay, now very simple. Why we do it scale then translation is the same reason why we don't scale then translation for gy equals to hx. We don't want our translation to be affected by the scale. We want to use the same numbers that they presented here, aka alpha and k, not needing for us to scale alpha to alpha over k. Why is that so? So let's say if you were to do the opposite first, translate first and then scale. You have y minus, let's say, alpha equals to, alright, let's keep it simple, for me, fx. You want to obtain what? Y equals to kfx plus alpha. Alright, so if you're to translate first, we then change this to y equals to fx plus alpha. Alright, so far so good. Now if you're to scale it, you need to scale it by k units. So k stretch factor k, scale factor k. Now you get y over k equals to fx plus alpha. You notice that we now get kfx plus k alpha. Slightly different, but because of that difference, it is wrong, quote unquote wrong, to translate first then scale. Obviously, you can translate first, but that means that you need to scale your translation at the get-go. Alright, alpha k, now you get back alpha. Alright, so to save yourself this trouble, simply scale first, then translate. Alright, so I don't know if I can have enough undo, so I'm just gonna cancel that right off. Okay, I think that's good enough. Alright, so we have y equals to fx, scale first, we get k fx. Alright, actually let's write this better. Y equals to k fx, alright? Thereafter, you translate, you get y equals to k fx plus alpha. Alright, and this is how I do it, really. I don't consider like y minus alpha over k and stuff like that because it's kind of logical, right? Y is basically fx. If you were to add an alpha, it means your y value increases by that particular alpha value or decreases by that particular alpha value. That means your value just simply increases or decreases going by the units. Alright, so that is the whole idea of combination transformations for our y and x, and particularly for y equals fx, where it is AMMA. Addition, multiplication for x, followed by multiplication, then addition for our y. All right, so AMMA start with x, then with y, only applies to y equals to fx. And again I repeat, this is not a hard and fast rule. Sometimes it's easier for you to scale first and then translate, particularly for your gy equals hx. Sometimes it's really difficult to see the translation then scale. Sometimes it's easier to scale first and then translate. All right, depending on case, usually an exception to translate and scale would be, let's say you're dealing with a lot of fractions, or if you're looking at conics. All right, so there we have it, combination transformations rather, and we'll look at the first example in the next video.